TA 你们的学生都到了吗？
喂，红色听到吗？有。
有。好，那南加大这边还没上线，但我们上课时间快到了，所以我想还是就准备开始。可能等一下南加大那边就会上线。
好。
那个教室的画面，你还是免费。
好。
Okay, so good morning, everyone. Today is our Taiwan part to give a seminar talk for the collaboration between USC and our school. So today's presenter is Professor Jerry Lin, Professor Lin Qiyu, who is the past director of Intelligent Robotics Center. So Professor Lin right now is online, and he has been working on the research in the field of robotics for many years. So I think he will be sharing many of his previous and current research results and performances. So I think it will be interesting to many of the class today. So Professor Lin, if you are ready, you can start. Okay, let's wait for a second. Yes. Professor Lin, your mic is off. Your microphone is off. Yes.
Okay. And today I will discuss, present one research topic on, we call it orchid tissue culture.
Sorry, are you doing the full screen right now? Because we don't see the full screen. We only see the software. Yes.
Okay, good. Okay, today I'm going to present one research topic called orchid tissue culture AI autonomous operating system. Okay, and you can see many beautiful flowers. And this is one kind of orchid, very popular. Actually, it was initiated from Taiwan, and I spent a number of years to study how to using the AI-based mobile operation to replace the human operation in tissue culture operation. Okay, this is my research team. Okay, and including two postdoc and a PhD student and a master student. And okay, this is one kind of orchid called Phalaenopsis. And this is the main propagation loop. Okay. You see that the orchid grows complies with three major steps. One is the base is a special kind of orchid, and then you have a good orchid. Then you have to go through the second operation called the tissue culture operation. The purpose of tissue culture operation is to create the number of shoot clumps so that you can move on to the final stage to grow this orchid in outdoor environment. Okay, so inside this main propagation loop, will mainly work on these few operations. One is you see the vessel, we call it flask, and the chute clamp, and the chute was kept inside this container and was inside the tissue culture plant for a period of maybe like 6 to 8 weeks, and they have agar on the bottom to provide nutrition. So the chute will grow into like the chute clamps, and so you see that there are maybe 30-40 chute clamps in one container. So the worker have to take it out one after one, put it into a metal plate. Then they have to separate it, okay? And because each chute clamp might combine 3 or 4, even 5 different chutes. So based on the SOP, they will separate it into single chute or double chute based on based on some standard. Okay, but before they conduct the separation, they need to conduct the measurement of for example, how many chute in this chute clamp, and also the length of each chute, and also the angle between the chute, so that they can based on the operation, the rule to conduct separation. Okay, after separation, and you will see that we need further to trim the chute. Trimming means that you have to cut out the leaf and also cut out some different part of the chute, so that after the separation and the trimming, you will see they are trimmed the butt. Okay, and these organ butt will be then placed back into a new flask or container. Underneath you see Canada, they provide nutrition. So the purpose of this operation is to increase the number. So for example, that from the left, there are 40 chute clamps, but after the separation, trimming, and they put it back, they become 120. So the number will be tripled or 2.5. So this is kind of exponential growth of the number of the chute. So they increase the number inside the tissue culture plant, mainly by this kind of operation. Okay, and this is the most human intensive operation in organ production group. And right now, in the entire world, there are 100% manual operation on this main propagation loop. So our purpose is try to using the AI-based robot system to replace all the human operation. And the autonomous chute clamp operations, including the 3 stages. First is the picking out from chute clamp the container or flask. Okay, in this stage, mainly the AI system were based on the vision and neural nets, and they determine where are the chute clamp and pick it out one after one. So you have the stereo vision system to determine how many chute clamp and where the position, and you also have a single camera to have the first temperature zone to play the chute clamp in order. And the second stage is called separation and trimming. This is the most difficult and challenging part of the autonomous operation. And we have to using a very complicated camera system. I'll explain that later, including 8 cameras, and also a robot and a turntable, and a lot of software to conduct, to work on each chute clamp, and then separate into maybe 3 or 4 butts. And after we trim, we separate the chute clamp and trim into the clean butt. Then final stage will be placed back to the new container. Okay. So I'm explaining here how to pick it out, and the system overview. That you can see that there is a 3D camera on top of the container, and so the 3D camera will determine where are the position of the chute clamp inside the container. And of course, we have conduct the transformation between each system, the mobile system, the camera system, and the OK container system, in order that what you see then where you can reach by the robot. And this is the image. Of course, this is 2D image that show that the 3D system, 3D camera system, you see from the top of the container. This, on the left, that's original point cloud model. Okay. Then we do some operation, so we get adapted the layer cropping. So we see upper part of the shoe clump. So we have a point cloud segmentation. So we find out there are many different shoe clumps. And then we will decide where to pick. From here you see that we decided to pick the bottom one, and from where. Okay. This operation is relatively easy, so we have done it successfully at least 2 years ago. You can see the video. On the top, that's the region obtained by the downward camera. And the robot holding a clip, and then pick up the shoe clump. This operation is relatively easier because it doesn't necessarily you only pick up one, because the whole purpose is you pick all of them out. So we can pick 1 or 2 because it's very difficult to only guarantee to pick one. And also in this operation, the lead will be trimmed, so it is not necessary to place the optimal careless on how not to hurt the leaves. Okay, then we jump to the second stage. It's called separation and trimming. You see that there are 8 cameras and 2 are top camera. And they are face up. Okay, so it was like Burberry. You place the shoe clump on the platform, so you have 1 from the top and 3 from the side. The 3 side camera system, they are apart by 120 degrees apart. And actually, each camera you see that is a stereo vision. Actually, there are 2 cameras paired. So we have 4 sets of the stereo vision. It looks like we have 4 people, 1 looking down, 1 on the side. 4 people, they are watching what the shoe clump is about. Okay, so the main purpose is to determine how we shoot in this shoe clump, and the length of each shoe, and also what is the angle between each shoes, because we need to determine all of these parameters so that we know how to separate and how to cut, how to separate and how to cut and where to cut, and also where to trim. Okay. On the right, you will see that we have an image taken by 4 directions, but this is only a 2D image because mostly using the 2D image and using the neural net to get a lot of knowledge out of that. And only in the small part of operation we're using the 3D on cloud because it takes a larger amount of operation time. Okay. So, but you see that the 4 different views, they see different directions. So some direction they see better view of the shoe clump, they can count through the number of shoes. Some they cannot be seen. Okay, the shoe clump separation definition and feature analysis is the formation of each perennial opposite shoe clump is diverse in terms of shape, okay, and color and size and distribution of shoes. That means that each shoe clump they have different formation, okay, and different formation means that they have different shoe, and each shoe will go to different directions and different lengths, different angle. Okay, so and also that you cannot guarantee you will see clearly all this information from one direction. So that's why we need to arrange 4 directions to count all these issues and to get full information so that we can make a right decision how to separate or cut. And we need to detect each issue. We need to provide a bounding box for each instance. We also should provide a mask for each single sheet before we can do further operations. Okay, then this flow chart shows a very complicated shoot clamp separation procedure. On the top, the blue background is during the development stage. Okay, you see that and on the bottom, the deployment that is including, of course, development, we need to do a lot of training. Okay, we do a lot of pre-training, and after we have done all of that, then we start operation, then you see that on the left, we have 4, because we have 4 pair of the stereo vision. So we each pair, we will get first 1 2D image. So based on this 4 2D image, we will do our eye cropping, and then after that we conduct a series of 2D image processing, including use deep learning, and we got a lot of knowledge segmentation, bounding box, and also object of interest information. Then we conduct another operation called best view selection. I will define it further later. The main purpose is that we have 4 views, but because we only want to spend a little time on handling the 3D point cloud formation, and so we need to select 1 from the 4, which one actually has the best view on the shoot cloud. So after that, we are using that best view, large scale vision, to get the point cloud, and then we will conduct a further analysis. So after that, we will move on to do the robot separations, and I will explain that later. And these are from the left, that's input image 4 directions for ascending shoot cloud. And then we conduct the neural nets and then deep learning. Then we have a predicted information, and each one has different understanding. Okay, then we using the best view selection. Then we will get we select the second one. Okay, this direction as a best view by some criteria, and I'll explain that later. And then we already know that this shoot clamp contains 3 bugs, and we also will calculate the length and angle in 3D model. So after that, those are knowledge, then we know exactly how to separate and where to separate. And these are shoot clamp separation multi-model fusion. Okay, we have input from the beginning, and the image is 3640, 640. Then we crop it into the smaller size for deep learning. And then we have unimodel representations. We get knowledge on the oriented bounding box. We got segmentation, and we got classification. Then we will do the data later fusion. Okay, then we know. And then we have a multi-model model. Then we'll get output. Output is interest information. This is example that we have image. Okay, then after we conduct a multi-model, we get a model. Then you see the shoe segmentation. We have 3 shoots, and we also get oriented bounding box on the butt, and then we got the angle of each shoot. Okay, this explains some further deep learning inference. Okay, we got input image, then we got augmentation information. This means that we have 1 camera image, but we will conduct the neural net operation by creating 2 copies of this image by rotating or vertical flip or horizontal flip. So that means that from one same photo, we can see from 3 different angles. So that increases the understanding of the neural nets. Okay. So after that, we conduct the pre-processing, and then we got the post-processing, and then we got predicted the image. I'll show you how it works. From the left, we have input image. Then, okay, of course, the top one is original image. Then we got a vertical flip image. We got a horizontal flip image. Then we using these 3 images as the input of the YOLO VB8 model. Then each model have a predicted information. They have different understanding. Okay. Then we will merge the instance from the 3 view and then into one. So that means that, for example, that we have an animal has 3 arms, and 3 people see from 3 different angles. Each one saw 1 arm, but they are different arms. But their knowledge will be combined together. They will tell, okay, this one has the arm. This is the example. Okay. Okay, there's a further deep learning inference, but this is a little bit detailed on. I will not elaborate on this one. Okay, this is about the best view selection flowchart. And as I told you that we have 4 2D image. And after deep learning, they contribute their knowledge on understanding what the shoe farm is. Then now is the time that we have to make a decision which one is the best view. So we created some parameters. First one is a clear index. Then we have no best view. And then we have distance ratio, part number ratio, and the length ratio, angle index. They're all about some idea that which one might be the better view. Okay, for example, that if you see a shoe clump, then your neural net understanding of shoe, and they are more rational, more reasonable to human understanding, they will get a high score. But it will take so much time to explain each parameter. So you will see that we are based on the neural net understanding on the shoe clump. And then we discuss some detail of them, then we find out the score. Okay, this is the example. We have a 4 image on the top, that's from 1 cent shoe clump. Okay, we have 4 views. And each view, the parameter score will be shown like those numbers on the top. And view 3, the third view was selected as the best view. And they have the best score performance. And by human vision below point that you see the view 3, you can see fully 5 shoot. And also the shoot between the angle between each shoot is actually more average, bigger than the rest of them. So this one will be selected as the best view. So once this view was selected as best view, the 2 images from the stereo vision will be used to create one clump, and then that will do further operations. And on the bottom, that's the second shoe clump. That's example 2. Okay, you have the 4 views. And then the second view was selected as the best view, so you can see that they understood this is there are 4 shoots, and also angle distribution are quite good. And then after you determine, okay, where to separate, okay, we have 3 cases. The law that there are only 2 shoots, so it's clearly we should separate the middle. Okay, because we don't want 2 shoots with a very wide angle to stay together. So they will be cut in the middle. And then the second one has 3 shoots. And so we need to separate at least 1 out of the next shoot. So the one with a wider angle other than the next 2 shoot group, on the right will be separate from the left 2. Okay. And then the one that has 3 shoots. So we still have to separate 1 from 2. And once we know where we want to separate, Then the next challenge is exactly which cutting point, okay, precisely where is the cutting point, where is the point out to cut, okay. Because right now you see the red line just approximate idea that I want to separate it from there. But now the task is to make a precise understanding on where to separate. From the case one, when the two shoot, they are wide open, and then we need only find out the central part is called the target area or basis. And then we know that this part separated two shoot, and so we find a middle point and also a tangent angle and to separate that. This is quite easy. And for the second case, the angle between 20 degree and 120 degree, like this one, then we need to exactly, we need to find out the best cut point, because if you cut a little bit to the right, you might hurt the butt of the right. If you cut a little bit further to the left, then you will cut the body of the butt of the second one, and that will make the growth of the butt growth not as good. Okay, so right now the operation is we need to find out where is the best point to cut and where. So this flow chart is tell you the procedures, but it's quite complicated. And so we see these region representations. Okay, and then second case, this one, and okay, and we were using the image rotation and to get this angle. Then we're cropping out the interest area. Then we'll do background segmentations and the Sobel filter, and segmentation again, edge detection, and separation point estimation, and control point estimation. And we do all this procedure operation just to make sure that the cutting point now is, you see that the red point is the first cut point. And then after that, we will have a precise cutting point estimation. This is how we conduct each operation. And this is another case that we need to cut from here. Then we do edge detection, and then we do some further operation. Then we will finally determine which should cut from here to here. Okay, the most challenging one is when the angle is very small between two shoots. And because when they are too close together, then it will be easy to cut into the one body or the other. So we pay extra attention trying to find out what exactly the separation line between two shoot lines. They are next to each other. Okay, so this is some computer vision techniques. We need to find out whether we want to check the starting point and the length. And this is an example that we will find, okay, we want to separate from the red line, then we find a region of interest. Then we get a feature scanning, okay, then we do the line filling, okay, and this is the example of shoot line separation estimation. There are some cases. The first one we decided to cut here. The different case we cut from here. Third case cut from here. Fourth case. There are different cases. And you see that this is very challenging for the robot to conduct fully autonomous operation of object with a diverse variation of format and shape, dimension, numbers. And so you need to have a very powerful neural nets, and also a very robust arrangement of region capture and sufficient computer vision to put together to have a high reliability of separation. Okay, then after separate, then you need to train, because in this growth cycle, the men need to increase the number of butt. So after separation, we will cut out the lead from here somewhere. Okay, the reason is that they have to cut out the lead so that the new shoot will grow from the side of the shoot. Okay, so next thing, in the next period, 6 or 8 weeks later, you will see one butt cut out of leaf here. They will grow the second shoot, third shoe and the fourth shoe become a new shoe clamp. Okay, and in order to get the best effect, they need to cut from the right position. The right position will be determined by the balance of the butt and also the split point of the lead, where the lead start to go into different directions. And this is the butt length. And they will each grow, they have different, each culture plant, they have different idea of this one. Mostly will be cut between 50% to 67%. Okay, but because we operate by parameter, so once the producer decided the number, the robot will understand where is the length, then we will cut accordingly. And again, this is the trimming, flow chart. I think this is relatively easier, so I will skip it. Okay. A little bit challenge is that, we have to separate first. After separate, and this original, this is a 3-shoot shoe clamp. After separate, we have the new retrieve the understanding on the, because it's a new thing. Original, the 3-shoot shoe clamp. Now this is 2 shoe clamp. One containing 2 shoes, one, and in different positions. So we have to quickly capture all the knowledge of that. Okay. So we have 2 groups. The first group, we need to know, where are the shoe and where are the butt and where to trim. Okay. Here you see that we have a trim here, and on the lower, the group 2, single shoe, we're trimmed from here. And this position adjustment, just like I said that, because the shoe clamp after separation, the position will change. So we have to deal with a new port clamp and new image. So we conduct some operations to repositioning and re-understanding the position. And this shows this example that this is on the left. This is a 2 shoe clamp. Okay, then we do the matching. Okay, because originally this is 3 shoe clamp, so this is a 2 shoe part, and we have to have a skeleton template and matching to from the 3 shoe. And where are the 3 shoe part of this part, and then we do the matching. Okay, then this is part of our equipment. I'll explain that later. Okay, then I will show you some video, and about how we operate that. And remember that on the left there's a 6-axis robot, then this circular one is a turntable, so we have 6 + 1 degree freedom to handle the shoe clamp separation and trimming. And I will show you the first one. This shoe clamp only have 1 shoot. So it's relatively easy, you don't separate. So you just trim it. Okay, I'll show you again. You have to pay attention to the turntable. The function of turntable is to turn the shoe clamp into one or position so that the robot will be handily cut. We don't have to move its elbow to long distance. So, for example, you are riding, so you cut in the convenient position. It's like the 4 o'clock position. But if the shoe clamp now cut the position is 11 o'clock, then you have to move your elbow all the way to 11 o'clock. Then you will take extra time. And so the robot, before the robot cutting, we will turn this turntable, turn shoe clamp into a position, orientation, angle, and so that the robot can cut. And please see that here again. Those are moving. Okay. Turntable turn so that the robot can cut conveniently. Okay, we have a case 2. You also see that when robot cut it, the nearby the suction pack will also suck the butt we want. So you don't need to cut and then you reach to suck it again. So you cut it at the same time you suck it. So the waste will be blown out of here. Then the shoe plug will be collected somewhere. Okay. And we see 2 chute cases. So these 2 shoes are separated in a wide angle, so they have to be separated. And so they are separated. Then the roller have to conduct a trimming on each of them. And I think we have some lagging. Sorry. So we see the second 2 shoes cases. First, we cut out the darkened area, then we trim 1 leaf. And we trim the second leaf, and at the same time we suck the 2 butt, and then collect it. Then we blow out all the waste. Okay, then we see 3 shoe cases. And first they separate into 2 chute column and 1 chute, and then they will further conduct trimming on the 2 chute part. They cut out the darkened area, and then they start to trim. Okay, after the second trim on the second shoe, they suck the 2 butt together. They're meant to stay together, and then they further to trim the last one. They cut out the leaf and then pick up the shoot. Let's see another case of 3 shoots. And they separate into 1 shoe and 2 shoe. And then we do trimming. They cut out the darkened area, maybe 2 millimeters, if they found, and then they trim the leaves. The video is from there. And this is trimming and a suck. Okay, let's move on to have 4 shoot. And first they separate into 2 and 2. And because these 2 shoot clump, 2 shoot are close to each other, so they will keep together. So we will chop off the darkened area first, and we'll start to trim the leaf out. Lagging. And cut out darkened area again, then we'll trim the leaf again. Again, lagging. Okay, we actually have successfully conducted in Shifan with more shoes, like the 5 shoes, 6 shoes. Okay, but they are based on the same idea. They have to separate into either 1 butt or 2 butt, and then they will trim. Okay, then final operation placement. after you train, you got a clean button. Then you have to place back into the new flask, a new container, and then for next cycle, another 6 or 8 weeks to then get more shoot butt number. Okay, this is shoot before they are placed back into the container. Please pay attention that on the left. They are green bounding box. They containing 2 buds together, and the red bounding box they contain 1 bud together. And they also have a direction because you have to place the bottom of the bud into the bottom of the flask of the container. Okay, so you need to have a direction. So we based on the deep learning and the robot vision location validation, then we place this back. And this video was recorded 2.5 years ago. And the robot will pick up the shoe clump on the table. Oh. Oh, the video is lagging. No, because this operation is relatively simple, so I move on and faster. Sorry, something wrong here. Okay, this is final placement in which you know that the robot can place this chute butter in the container in a much ordered fashion, and it provides a better positioning for the bud to grow in the next cycle. And also this is a very important page for this AI-based the fully autonomous operation system. And you see in the middle that tissue culture propagation parameters. Okay, in the tissue culture plan, they have different parameters to operate. They have different culture medium. Okay, they put on different nutrition. They believe that is the best for that. Actually, it can change. But okay, then also they have a shoe cutting SOP. For example, how to wear, in what situation you keep the 2 shoes together, what circumstance, how long on each length, or what angle. And also after you put a clean bud, the container into the tissue culture plane, then the next 6 or 8 weeks, they're under the illumination plan and also under the temperature control, humidity control. Okay, also determine how long. And for illumination, they might using the LED and they will change the different color percentage. And there are a lot of control parameters. And each tissue culture plan, they have their own secret. But they don't know, and I asked them, they don't know they are the optimal or not. Because they don't know, they have no way to know that their parameters are best. But they know that these are operation parameters for them. They are using okay, but they are not necessarily best. Okay, the issue is that if we using this AI-based autonomous operating system, remember that each container, okay, we have to take it now. Then in order the robot can do fully operation, then we have to understand and calculate in each shoe clump how many shoes, and length of each shoe, and also angle between shoes. And these are best data information to evaluate how good this tissue culture operation is, because we can get the statistics. So it provides the chances that the tissue culture plan can often they change some parameters in a small percentage, and then conduct a variation parameter or experiment. And only 6 or 8 weeks, when they go back again, and we will record all the new information and give you a report, and your experiment is good or not. So you can, based on this very fast returning information, to move on to a better parameters. Okay. Okay, so that's what I call a self-evolving tissue culture operation system. All based on we have this special capability. We can recall all the key information of each tissue clone, and human operation they cannot do that. And this shows that the tissue culture autonomous operation system flowchart. Like if you want to make a machine to do that, you need to have a flowchart or arrange the sequence. Okay, but you know that many, including 3 stages. One is picking out, one is the separation and the trimming. Final one is placement. Of course, you need to have a lot of supply. For this operation, you need to have an automatic supply of the container and disinfection system, and also you have to automatically provide a new container and sealing, a lot of these kind of things. And the best of using this AI fully autonomous operating system is it actually very cheap compared to human. Okay, so we assuming that now our speed is 75% of human equipment operation speed, and then because the robot, the AI robot can be trained better and better. So we expect that 2 years from now, our target is reach 100% human speed. And also the robot system for 24-hour basis, 3 times of labor shift a day. So the cost will be about 70% only compared to Taiwan human salary standard. And this is video show that how the system will look like. The container supply, and then they are sealed. Take out the cover, and then pick out the shoe clamp. One after one, place into a shoe clamp tray. Then the shoe clamp tray will move on to the second robot to conduct the separation and the trimming. And after that, they were sealed and put into the container storage. And last 2 months, I went to Europe to visit the 3 largest tissue culture company, and then we discussed we will create a new startup company to move on to change the operation of this orchid industry in the future. And I think that this is the end of my speech today. Thank you.
Thank you very much. So our partner from USC is also online, Professor Yong Chen. Let me, because I didn't introduce to you our speaker. So Professor Jerry Lin is our past director of Intelligent Robotics Center. So from his presentation, you can see he has developed a really complete production line aided by robotics on we can call agriculture applications. So do you have any comments to Professor Lin?
Yeah, sure. Hi, Professor Lin. Nice to meet you.
Nice to meet you.
I have one quick question. So you have you call it bud, so you are keep on using or cut out the bud and then regrow into shoot, right?
Yes.
And then I saw you blow the shoot into some container, some boxes.
Yeah.
So that shoots will be used to sell or to taking out some, because that's your final product to make money, right? Is that right or no?
Okay.
That shoot.
Okay. You see the orchid flower you can buy in the market, right? Grown up, you see the flower. But they start from the one shoot coming from tissue culture plant. They sell the one single shoot and sell to the grower. The grower will be placed in a small pot in outdoor. And after 6 months, they grow bigger. They change into the middle pot. After 6 months, they change to the bigger pot. And then they'll have flowers. So in outdoor, there's about 1.5 and 2 years. But inside the tissue culture plant, they need to increase in the number because they have a good bud from an excellent orchid. Okay, but the excellent orchid, they're limited, so they take out some bud. Then they will create more number of that, and by exponential increase, each cycle 6 to 8 weeks, the bud will increase 3 times. So 3, 3, 9, and 27. So you see the operation is just try to increase the number. So the since rollout is that's for the waste, the lead. They don't need a lead, right? So because we already set the bud we want into the container, they blow out these they wasted. Okay, but this is not the 100% operation in tissue culture plant. But this is a main operation plant, main operation loop. But before they want to sell the shoot into the grower, in the final stage they will not trim. Okay, they will pick out a bigger single shoot. Then they don't cut out the leaf. They place back into the container again. Another 6 or 8 weeks, that become a very big shoot, single shoot. Okay, and then those are they will sell to the grower. Okay. But not only about 10% operation, 90% operation in tissue culture plant is to continue to take out separation trimming and put the new bud into the container. This is 90% their operation.
I see. That's interesting. So for this type of bud, they or shoots, they will continuously grow and then cut and grow. Are there any limitations to them? How many round or iterations they can grow?
Actually, I don't know their limitation. Okay, because they can continue to grow. Okay, because if you cut out the leaf, they will tend to grow the new the bud from the side. So they always do that. Okay, so there are no limitations. Say, okay, you have to do 5 times a day. You cannot continue to do that. I never know this limitation.
Wow. Okay, that's fascinating. Thank you.
But Professor Bodin said that this is an agricultural operation, but I think the core technology is about how we can quickly and precisely understanding the concept of object your interest to operate. It's not necessarily agricultural sense.
Yes, true.
I mean, anything with varied formation, length, dimension, shape, you need to know how to handle that. Okay.
Yes, thank you. So just for Professor Ling's information, Professor Yong Chen will be coming to Taiwan on the week of Christmas.
Okay.
So I hope at the time we can
chat.
Yeah. So because of the time, I think I will skip the questions from the students.
Okay.
They may need to run into other courses. So thank you, Professor Ling. Thank you, Professor Chen. See you next time.
Okay, bye-bye.
Okay, thank you. Bye.
Bye.